All right, so today's class, we're looking at topic 2, describing structures. So, what are some things that a designer or an architect or an engineer look at when they're planning a new project? They have to look at function. What is its purpose? Aesthetics. That's like, is it pleasing to the eye? Does it look nice? Safety. They have to look at materials, what kind of materials they're going to use, what kind of joints they might have to use, and also cost. They have to look at cost factors, and they usually have a budget that they're working with. The diagram here, Trestle Bridge. This is in Lethbridge, Alberta. It was the longest structure of its height when it was built in 1909. All right, so back then it was the longest structure of its height in the whole world. It can carry trains 97 meters above the river for a distance of 1.6 kilometers. Next, we'll look at function. So function is, what is the purpose? What is it going to be used for? All right, so a function is the main purpose of the structure or object. So most structures, they may have several functions. For example, a bridge, it has to support the vehicles, it has to support the people, but it also has to be able to support its own weight. So bridges, if they're made of steel and concrete, that bridge itself can weigh more than the cars and trucks that are traveling across the bridge. Here we have running shoes. So they have to be able to grip the ground or the gym floor. They have to be comfortable, so they have to be able to cushion your foot bones from the impact of running. People sometimes want to make sure they're waterproof. And they also have to prevent the feet from getting hot and sweaty. So they have much more going into them than what meets the eye. These are just an example of those Rube Goldberg inventions. So these were like these crazy inventions just for like something, for like a simple task. So they were like these cartoons made. So next is aesthetics. This is the study of beauty in art and nature. So is it aesthetically pleasing? Architects or engineers or designers, they'll use, for example, shapes. Maybe they're being repeated or carefully arranged. They'll use interesting textures and colors that are carefully chosen to be harmonious and contrasting. They have to choose appropriate materials and methods that are used to make the structure. So usually architects and engineers are going to try to keep their designs simple, because clean designs, they look better than overcomplicated designs, overcomplicated busy designs. Here we're just looking at marble columns. So here in classically designed Greek buildings, they look beautiful, they're functional, they're very strong, but they also are very expensive. Here it is the Museum of Civilization. This is in Quebec. It kind of mimics like a seashell in design. It was designed by Métis architect Douglas Cardinal, and so he uses a lot of Aboriginal design and aesthetics with modern technology. Okay, so also using lots of elements of nature in designs. Next is safety, so designing for safety. So an example is elevators. Maybe you've seen this when you walk into an elevator, like a warning sign, do not exceed a maximum capacity of like 5,000 pounds, maybe 20 people. All right, so the elevator is strong enough to carry a much larger load than could ever be squeezed into it, but they have to design with a margin of safety. All right, that's referring to having extra strength so that it'll withstand much larger load than it would normally need to carry. All right, so that's there for safety. So almost all structures are built with a margin of safety. So in Canada, for homes, when we're building roofs, they are designed to support enormous weights. right? Because we can have a big dump of snow, and we want to make sure our roofs don't collapse, right? So that they don't collapse under that weight of snow. Bridges as well are designed to carry much larger loads than would ever occur. So even if there was a traffic jam um, with like large transport trucks, that bridge will be able to withstand that large load. So that was called margin of safety. Next, balancing safety with cost. So if you're trying to make these structures stronger, it's going to be more costly. It's going to be more expensive because maybe you're using more material, maybe you're using more expensive material. Skilled craftspeople, they're going to cost more than inexperienced workers. So when designing these engineers, these architects, and so on, they have to be able to plan structures to withstand conditions that might occur, but they also have to be within their budget. All right. So examples are like conditions that might occur, like floodwaters, an earthquake, that sort of thing. Impact of floating debris if there's a floodwater. So here, this is an example. This was Edmonton's Grote Bridge. It got damaged by floodwaters during construction. So in 1954, the partially completed bridge was damaged by the flooded North Saskatchewan River, so you can see here. But that was during construction. Let's pause here. So next we will talk about materials. So the properties, which are the characteristics of the materials, must match the purpose of the structure. So we can take different materials, we can combine them to give different properties as needed. So like we saw in the video. So reminder about what properties are. These are the characteristics of materials. So like its color, its odor, its density, and so on. Those are some examples of properties. So we'll talk about composite materials first. So for example, steel rods and cables. They can support very strong tension, which are pulling forces, and they can bend and twist if compressed, if they were pushed together. So that would be a composite material of steel rods and cables. Concrete. Concrete's a good material because it resists large pushing forces, but it does break if it's pulled or twisted. So we can take concrete and use it with other materials to make it stronger. So when we talk about composite materials, it's made up of several different materials with different properties to fulfill a specific purpose. For example, flexible plastic. It's formed around a nylon mesh, and it's used in like a lightweight garden hose to strengthen it against the pressure of water. Another example is called reinforced concrete. Therefore, it can withstand both the tension and compression. So reinforced concrete is used to make buildings, bridges, other large, strong structures. So basically what's done is you take the concrete, it's poured around steel rods, and that will produce that reinforced concrete. So if something does happen to the concrete, if the reinforced concrete breaks, the steel rods are still there to help support the structure. Layered materials can be used. An example, a Tetra Pak. It's a beverage container. It has layers of thin sheets of paper, plastic, and aluminum foil, therefore making the container waterproof, airtight. It's lightweight. You can easily transport it, and it's inexpensive. All right, so you can see the layers here of aluminum, paperboard, polyethylene, which would be like a plastic. Here, wood, so layers again, like pressed wood and so on. Layers of different materials pressed and glued together will produce useful combinations of properties. In car windshields, there's a plastic film inside the safety glass, which helps resist shattering. Drywall panels on walls, on the floor, they contain laminations. So laminations are layers of different materials. All right, so like here for plywood, we can see like layers. So lamination, it's a process in which a layer of material is pressed or glued onto other layers. Next, woven and knit materials. So like knitting, crochet, so on. Hair-like fibers are spun together, like they're twisted together into long, thin strands of yarn. A loom can be used to weave 2 or more pieces of yarn together in a crisscross pattern to make cloth. And these knit materials, they can stretch in all directions. So therefore, they can fit well over complex shapes like human bodies. All right, so here in this diagram, it's like an interlocking yarn. So therefore, the forces are being spread throughout the fabric. So choosing materials. So how do they pick materials? So they have to consider all of these. So to pick the most suitable materials for a structure, they need to consider cost, right? If they're looking at just cost, cheap materials can be poor quality, so therefore they wouldn't have a strong enough structure. They have to look at appearance or aesthetics, right? Buildings and bridges, they have to last a long time, and therefore they have to remain attractive for a long time without requiring expensive maintenance. They also have to look at environmental impact. Using recycled materials will help preserve Earth resources. Avoiding materials that use harmful chemicals or using materials that don't decompose or recycle wouldn't have a good environmental impact. So just using environmental friendly products. Energy efficiency, choice of materials can reduce the amount of energy a structure requires. So for example, if we're looking at appliances like refrigerators, freezers, washing machines, and dryers, if they're using appropriate materials, it can reduce the amount of energy people have to spend. Pause here. So next we are looking at joints. So how can different types of joints be used to fasten a structure together? Now keep in mind that these structures, they will often be weakest where their parts are joined together, right? So these joints need to be quite strong. So there are joints that are called mobile joints. So these are joints that allow movement. That's why they're called mobile. There is movement in these types of joints. Examples would be like door hinges or elbows, pins in a bicycle chain. So they hold the parts together, but they still allow movement. They are trickier to make, and lubricants are usually required so that there is less friction, so that the parts can move smoothly. Examples are like door hinges will start to squeak, bike chains will wear out, even human joints develop arthritis because of all that friction. All right, so there's just some examples here. Like here we have the ball and socket joint in our shoulder. Here we have a lid on a photocopier, a trail hitch, a door hinge. Those are examples of some mobile joints. And then rigid joints, these are joints that are designed to stay fixed in place. There's no movement allowed. Example would be like a nail and a screw. There's 5 categories of rigid joints we'll talk about: fasteners, ties, interlocking shapes, adhesives, and melted joints. So fasteners, these are things like nails, and staples, bolts, screws, rivets, dowels, holes that are made. These holes that fasteners make will also weaken the materials they fasten. So keep that in mind on where that hole is made, but also the material itself can weaken, like wood and so on. Interlocking shapes, these are carefully shaped parts that can hold themselves together. Think of things like Lego bricks and paving stones. These are just some examples here. This is a folded seam. It's a type of interlocking joint where they kind of like hook together. A clothing hem as well, and stitching. That would be another type of interlocking shape. This one is a dovetail joint, so notice how you have this structure here. It'll fit right into here, kind of like the Lego bricks. Ties, these would be things like thread or string or rope that can fasten things together. So here, like sewing machines can tie two threads together and stitch a seam. Here we have moccasins. They are sewn by hand with a strip of leather. We also have some leather lacing here to keep it together. Next are adhesives. These would be like glues. They would include like any sticky substance like a glue or an epoxy cement. It's used to hold objects or materials together. There are thermosetting glues. These will harden when they cool. So think of like glue guns. They heat up and the glue becomes more melted, and then as it cools, it will harden and dry. There's solvent-based glues. They will harden as they dry out. Now glues, they can soften in water or under very hot conditions, so that would be like a downside of glues. Now sometimes a glue might be stronger than the substance it joins, and that can cause the material next to the joint to break. Another thing is that glues can be a health hazard, all right, if you touch it or if it's ingested or something like that. All right, so here we're just looking at glues. It creates like a bridge between two surfaces. It will lock it together. There's a video here on Post-it notes. We'll watch that a little bit later. Melting. This is another way of joining pieces together. So pieces of metal or plastic can be melted together. Welding, this is a specific process in which pieces of metal or plastic are fused together by the application of heat. There's another type, is soldering. This is in a process in which a melted material is applied to a different type of material. So that melted material will harden when it cools, and it'll form this rigid joint, and it'll hold the other material in place. Protection is required. You're working with hot metals and lots of heat. So wearing these masks to protect their eyes, as well as protecting their skin as well.